In question 1, they have given a space to graph, and part A says on the axis below, draw these two graphs. Okay, and in B part, they're saying that use the graphs to solve this. So the detail method is the one I have done here. On right side, you can see a table. In that table, I will write x here and y here. First, y is x minus 5 absolute. So I will write just absolute x minus 5. In second function, y is equal to 6 minus absolute 2x minus 7. And this table I will fill up with the help of x, because x is the only variable in here. And they have shown the scale is from -2 to 8 for x. We will use all these numbers to get the best result possible. With absolute functions, the problem is we are not sure about the vertex, because a graph looks like this, a V-shaped graph. Where is the vertex is the challenge in absolute graphs. So best thing is that try to draw all the points they have given here, substitute them, and then you will get the shape of your graph, not necessarily the vertex, but once we draw the graph, the two lines will meet at a point which will be our vertex. That I'm going to show you. So I've written from -2 to 8 on the x column. Now I will calculate absolute x minus 5. Absolute x minus 5. So first it is -2. Let's put -2 here. -2 minus 5, which is absolute minus 7. And removing absolute will make it positive 7. So our absolute x minus 5 is positive 7. Similarly, I will substitute this -2 in second equation they have given. 6 minus 2 times -2, that is our x value, minus 7. And if you do them step by step, it will be 2 minus 2 is -4, minus 7. Minus 4 minus 7 is -11. That gives us 6 minus -11, but that -11 will become positive 11 when we remove absolute sign, and it will be 6 minus 11. That means we will get -5. So -5 here. I have found the corresponding y values for two functions for x equal to -2. Similarly, I will calculate for -1 onwards up to 8. All these points. I'll fill up the table. When this video resumes, you will see that this table is full and their graph are drawn. So I completed the table. Red color is for absolute x minus 5. The blue color is for 6 minus 2x minus 7. And these are the graphs I got when I joined the points. The red graph is perfect. We know its vertex is at 5. But we didn't get a vertex here. But we can see if we continue this line, it will be something like this, and our vertex will be here. So I kept it to show you that if you don't get a vertex, no problem. Join others and you will get an idea where the vertex is. Now, we've done the A part. Use your graph to solve the inequality, B part says. And it says that x minus 5 graph should be above. Greater than means above 6 minus 2x minus 7 graph. So the blue graph should be below the red graph. That's what it's saying? Yeah. So you can see before this point here, this red graph is above blue graph. That's our answer. In this case also, the red graph is above blue graph, and that's our answer. That means we already got two situations under which this graph shows this inequality. And final answer we will write will be, we give our answers always in terms of x. So here the x is positive 2. When x is less than 2, when it is below 2 in this direction, red graph is above the blue graph. That's what we want. And second one is 6, where after which the red graph is above the blue graph. So second answer is x is greater than 6. These are the two solutions of this inequality. Next question. is simultaneous equations. Solve the following simultaneous equations. Give your answers in this third form. Okay, so we can use substitution method in this. So let's substitute x into the other one. So we'll have to isolate x in the first one. It becomes 3 minus y. So let me substitute this in second equation, which is this one. 2 times 3 minus y minus square root 3y equal to 5. So we'll open the bracket so that we can club the y's together. So 6 minus 2y opened minus square root 3y equal to 5. And these two y's, we will combine. This 6 will go to the 5. So minus 2 minus square root 3 y. I took y common from these two. And 6 went 5 minus 6 here. So y becomes 5 minus 6 is minus 1 over minus 2 minus square root 3. We can see all of them are negative. So whenever all of them are negative, we can change the sign. So let's change the sign to positive so that we get a cleaner y. So we got it. But they're saying give your answers in the form of a plus b square root 3, which is not here. That means we'll have to rationalize the denominator by its conjugate. So 2 minus square root 3 multiplied up and down, and now we will multiply this. 1 multiplied by 2 minus square root 3 is 2 minus square root 3. This is in the format of a plus b multiplied by a minus b, and the identity for a minus b, a plus b multiplying is a square minus b square. So we will just write a square. What is a? A is 2 for us. So 2 square minus square root 3 square. So 2 minus 3, 2 minus square root 3 rather, divided by 4 minus this square and this cancel out. 4 minus 3, 1. So we got our y equal to 2 minus square root 3. Now we have to substitute this in this equation so that we get x. So x will be 3 minus y, and y is 2 minus square root 3. So it comes out to be x equal to 3 minus 2 plus square root 3. 3 minus 2 is 1 plus square root 3. This is the value of x, and value of y was already known to us. That too in the format they wanted. Alright, let's go to the next question, which is this. They have given a trigonometric graph, and this is the equation y equal to a cos b x plus c. This is the general format of this equation. Okay, where a, b, c are integers, find them. Okay, first of all, let's focus on a. A represents the amplitude of the graph, and amplitude is, let me write here, amplitude, the formula, you should remember this, is the maximum minus minimum divided by 2. When we subtract minimum from maximum, we get the distance, vertical distance between them, and by 2 we divide that distance. That gives us exactly the half height of that distance, which is amplitude. So let's say what is amplitude here. So maximum is how much? 2. The y value is 2 minus minimum y value is minus 4 divided by 2. That is 2 plus 6 divided by 2, 3. So amplitude is 3, a is 3. Second thing, we have to find this c. C is called axis. Axis is the middle line of the graph between maximum and minimum, the middle line, which is average of the two. For average, we add maximum and minimum and divide by 2. That's how we get the mean or average of the two. So axis in this case will be 2 plus minus 4 divided by 2, and that is minus 2 divided by 2 minus 1. C is minus 1 because this is minus 1. C is the axis, and it makes sense. Minus 1 is the middle line between 2 and minus 4. Now the challenge is to find b, and for b we should know that b is always 2 pi, because it is in radians, 2 pi divided by whatever is the period of the graph. To find the period of the graph, take two consecutive maxima or minimum. So let's take these two. These are two consecutive maxima, and the horizontal distance between them becomes the period. And this is 0, this is pi. The difference between them is pi, and that's why our period is pi. So we can write that b is 2 pi over pi, where pi and pi cancel. B is 2. We found all three of them. Let's see what is B part about. Another curve has equation y equal to 2 sine 3x. Write down its amplitude. Okay, as I told earlier, the amplitude is the coefficient of sine or cos. So the coefficient is 2 here, that becomes amplitude. Period in radians. So we said earlier that b is 2 pi divided by period, right? Similarly, period will be 2 pi divided by b. What is b in this case? In this case, b is 3. So it will be 2 pi divided by 3. That becomes the period. That's straightforward. Question 4. Solve the equation of this log. Give your answer in exact form. So to solve this equation, we should isolate x. So to isolate x, this log must go. Whenever we remove log from one side, the other side becomes the exponent of whatever base we have. So it will be 2x minus 3, and half becomes the exponent of 6, square root of 6, that is. So 2x equal to, I will write this as square root 6, and that is 3, which comes to the right side and becomes positive. So x will be square root 6 plus 3 not the whole square, divided by 2. This is the exact form, that's what they want. What next? Solve the equation. This one, give your answer in exact form again. So we can see here there are two natural logs which are equal to 1. So whenever we want to combine two natural logs, we should do that. So 2u, this len is subtracting this len. So whenever we combine the two, one divides the other, that's the logarithmic law. And that will be equal to 1. Two natural logs became one natural log, and we followed the law of logarithm. Now, problem is we have to remove this natural log to get the value of u, or isolate u. So whenever we remove a log, just like the previous term, it became 6 to the power half because 6 was the base. Here e is the base, so it will become e to the power 1, and we will be left with 2u and u minus 4. Now our aim is to find the values of u, so we have to combine them. How can we combine them? First, multiply this u minus 4 to the right side. We get it as 2u equal to e u minus 4. I'm not writing the exponent 1 now because it is not needed. So 2u equal to eu minus 4. E and 2u minus eu will be minus 4e. This eu I brought to the left side so that these u's can be taken common from the 2, and we can isolate in that process. So u is taken common, we are left with 2 minus e here equal to minus 4e. So u by cross multiplication, this will divide. Let's divide it here. This is how we do it. This and this cancel out. U equal to minus 4e over 2 minus e. And if you do not want to leave this negative there, so we can change the sign of all three of them. That's what we can do. One of the previous questions we did that, if you remember. So it will become positive 4e divided by negative 2, and this e will be positive, so they will change their places. This is the value of u. Let's see what is the next one. Solve the equation, and it has some exponential expression, and we have to solve this again. So let's do it. 3 to the power y equal to 9, and I am taking this 27 2y to the power 2y minus 5 to the other side so that it becomes simpler. 227 to the power 2y minus 5. Done. Now this is 3. 9 can be converted into 3 to the power. 27 can be converted into 3 to the power. Let's do that. So 3 to the power y equal to 3 square, then 27 is 3 cube to the power 2y minus 5, right? So now we have everything in 3. Let's see if we can do something else. 3 to the power y equal to 3 to the power. Now this is base 3, this is base 3, they're multiplying, so their exponents will add up. So 2 plus, and their exponent over exponent, they will multiply. So 3 times 2y minus 5. You can pause the video. If you don't understand, just try to understand. 3 to the power y remain 3 to the power y. This 3 and this 3, because they are same bases, when they multiply, their exponents add up, and that's what happened here. There was an exponent over exponent, that's why they multiplied. Okay. So now bases are same, we can ignore bases. Y equal to 2 plus 6y minus 15. Okay, 2 and 15 will stay here, become minus 13. Y minus 6y will go to the left side. Let's complete here. Minus 5y equal to minus 13. Y equal to divided by minus 5 both sides. They cancel out. 13 over 5. Question 5. It is about an identity that we need to prove. I have given some tips in one of my videos. I will give the link in the description, where I have given you tips how to prove different types of identities, and I have solved all the identities of the textbook, Gcse textbook. So we'll focus on left hand side, and one of the tips is that whenever cosecant is there, just convert it to sin x, so that we can convert this into tan x and secant x later on. So 1 over sin x plus 1. Okay, if we focus on the denominator, we can write this minus as sin x over sin x. Why? Because we want to club the two. So similarly, it will also become sin x over sin x. They will have same denominators, so we can make them 1. So 1 over 1 minus sin x over sin x plus 1 over 1 plus sin x over sin x. A fraction inside a fraction is little odd. So we know 1 over means reciprocal. Reciprocate this one. So if I reciprocate the denominator, I will be left with sin x over 1 minus sin x. Basically, the denominator of denominator becomes the numerator. So sin x over 1 plus sin x. Now, they are one term on the right hand side, but these are two terms. We want to make them 1. And to make them 1, we will multiply the denominators of each other. This is the tip number 2, which I have given in my videos. So 1 plus sin x over 1 plus sin x, we multiply the first one by the denominator of the second one, and second one will multiply by the denominator of the first one. So now we can multiply sin x with 1 plus sin x. We get sin x plus sin square x plus sin x minus sin square x over, since these are same denominator, we can write them once, which is 1 plus sin x multiplied by 1 minus sin x, and same identity we used earlier, a plus b, a minus b. If that is the situation, it will be a square minus b square. So it will be 1 minus sine square x. And we know 1 minus sine square x is cos square x. Sine square and minus sine square x cancel out. We are left with 2 sine x. Now, our target is to have tan x, secant x, and 2 is already there. So we can separate the denominator. We can write 2 sine x over cos x multiplied by 1 over cos x. Basically, I divide cos square x into two parts. So now sine x over cos x, this is a famous identity. We know it is 2 tan x. And 1 over cos x. The reciprocal of cos x is secant x, which is exactly the right hand side. Proved. What's next? Hence, solve the equation. The left side is exactly what was there in the first part, and the second one is 5 cos x. So the left hand side was converted to 2 tan x secant x. 2 tan x secant x equal to 5 cosecant x. Again, we have a combination of tan, secant, and cosecant. Let's join them with the help of sine and cos. Tan x will be sine x over cos x. Secant x 1 over cos x equal to 5, and cosecant x will be 1 over sine x. The reciprocal of sine x is cosecant x. Now, let's combine all of them to the left side. So sine x goes there and multiplies with this sine x. So it becomes sine square x. Cos x and cos x multiply, they become cos square x. 5 stays here, and this 2 goes and cross multiplies to the denominator where we are not left with anything. So we'll just write 2 here. Whole process was to simplify the expression. Sine over cos is tan, so sine square over cos square will become tan square x equal to 5 over 2. So let's square root both sides. When we square root something, we get both plus and minus. So tan x is equal to plus and minus square root 5 over 2. Plus and minus means from 0 to 360, all 4 quadrants will have the solutions, because tan is positive here, and here it's negative here and here. So all 4 quadrants have answer. We will now put tan inverse x equal to tan inverse square root 5 over 2 in our calculator, and we'll get the acute angles in all 4 quadrants. No plus minus here because we already know the quadrants. We just need this acute angle. By the time I do this, I would request you to subscribe to my channel, like and share this video with your friends, and let this knowledge spread out, and all of us get benefited. I get motivated to make more videos like this. Thank you very much. So tan inverse square root 5 over 2 gives me 57.68. So 3 second figures, I'll write it 57.7 in all 4 quadrants. Please keep in mind, these angles are always with the horizontal lines only. This is a horizontal line, this is a horizontal line. Never ever with the other lines. Okay, let's write the first answer. First answer, we always start from 0. So the first answer will be this one, which is 57.7 degrees itself. Second, to the next line. This one is 57.7 less than 180. So x2 is 180 minus 57.7 degrees, which is 122.3 degrees. Third angle, it goes up to here from 0. We are counting from 0 again. So 180 and plus 57.7 more. 180 plus 57.7 degrees, which will be 237.7 degrees. Okay, x4, the last one. We go further to this line. It will be 360 minus 57.7 because it is not reaching 360, it is before that. So 360 minus 57.7 degrees, 302.3 degrees. These are the four solutions. 1, 2, 3 and 4. Question 6. Part A. Express y in terms of x if x is 2 plus secant theta and y is 5 plus tan square theta. That means our left side should be y equal to something in terms of x or x square, x cube, whatever they want. But there should not be any theta. Now, if you notice here, we have a secant theta in first x equation and we have tan square theta in y equation. How can we eliminate them? We can use this identity. The identity is secant square theta equal to 1 plus tan square theta. This is the identity we can use. This is given in your formula sheet. But we don't have secant square theta, we have secant theta. So what can we do? We can isolate secant theta in the first equation. It becomes x minus 2 equal to secant theta. And now square both sides so that we get secant square theta. So the right side will be secant square theta. What will be the left side? Square of this, which is, okay, let's leave it like this, x minus 2 square. Now, since this secant square theta is 1 plus tan square theta, x minus 2 square will be 1 plus tan square theta. So tan square theta becomes x minus 2 square minus 1. And that was our purpose, because second equation has tan square theta. We got a tan square theta in terms of x and we'll just substitute it there. So let's substitute in this equation y equal to 5 plus tan square theta, and tan square theta is this, x minus 2 square minus 1, and 5 minus 1 is 4. So y is 4 minus, rather plus x minus 2 square. We got y in terms of x, theta got eliminated. Second part, B. It says find dy over dx in terms of x. Okay, so we'll just differentiate this. Dy over dx equal to, differentiation of 4 will be 0, so I'm not writing it. Differentiation of x minus 2 whole square will be, 2 will come in front of the bracket, x minus 2 remains x minus 2, and the exponent goes down by 1. Further, we multiply by the differentiation of what is inside the bracket, which is just 1. So it will be 2x minus 2, or if you want to write 2x minus 4. That's what they wanted. In terms of x, this is dy over dx in terms of x. Let's move on to the next one. A curve has the equation found in part A. Okay, what was the equation? Y equal to 4 plus x minus 2 square. Find the equation of the curve to the tangent. Equation of the tangent to the curve when theta is pi by 3. So for equation of the curve, we have this general format, y minus y1 equal to mx minus x1, where x1 and y1 are the specific values. We have not been given x1 and y1, so we have to find it. So what was the equation for x? For equation for x was, I'll go to there, 2 plus secant theta and 5 plus tan square theta. So x was 2 plus secant theta, y was 5 plus tan square theta. So x1 becomes this at pi by 3. So let's find x1. 2 plus secant pi by 3. So secant pi by 3 will be 2 plus, because our calculators don't have secant, we write 1 over cos pi by 3. Cos pi by 3 is half. So it becomes 2 plus 1 over 2. And denominator of a denominator becomes numerator. That means it will be 2 plus 2, which is 4. Our x1 is 4. Alright. What about y1? y1 is 5 plus tan square theta. 5 plus tan square pi by 3. 5 plus tan theta, tan pi by 3 is square root 3. Because of the square, it will be squared. Please keep in mind, if the square is here, it is square of the whole ratio. If square is here, it is square of the angle only. And that's why we write square with the ratio so that we square its value. And that's what it will do. Square root 3 and square root cancel out. 5 plus 3 is 8. So we got y1 equal to 8. What is left now? M. Let's find m. dy over dx. What was dy over dx? It was 2x minus 4. So dy over dx equal to m at theta equal to pi over 3, which was 2x minus 4. 2 and x is 2 plus secant theta minus 4. We got x value as 4, right? So we can replace this whole thing by 4 because 2 plus secant theta gave us 4. 2 times 4 minus 4, which is 8 minus 4, 4. Finally, the equation will be y minus y1. We got y1 as 8 equal to m. M we got as 4. X minus x1. x1 was 4. So y minus 8 equal to 4x minus 16. And we can bring everything to the left side. It becomes y minus 4x. And this becomes plus here. 16 minus 8 will be 8. This is the equation of the tangent. They have not specified any format for this. We have done it. Okay, this is the equation. Question 7. The vector p has a magnitude of 39. Okay, and it is in the direction of minus 5i plus 12j. It is not minus 5i plus 12j, but it is in the direction of this one. That means this vector and this vector are parallel. Okay, q has a magnitude. Okay, q has a magnitude of 34, and again the direction is same as 15i minus 8j. So since they are parallel, their magnitudes will be a scalar multiple of each other. So we'll find the magnitude of this one first, which is minus 5i plus 12j. Let's find its magnitude, which will be minus 5 square plus 12 square, which is square root 25 plus 144 and square root 169 rather, which is equal to 13. That means the magnitude of p is 3 times the magnitude of this particular vector. Since they are in same direction, we will multiply the given vector minus 5i plus 12j as by 3, because 39 is 3 times 13. That means this vector is actually 3 times longer than this vector. Since the direction is same, that's why we multiplied the same vector by 3. So we get p as minus 15i plus 36j. Let's do the same thing with vector q also. First we will find the magnitude of 15i minus 8j will be square root 15 square plus minus 8 square, which is 225 plus 64 square root 289. Square root 289, which is 17. 34 is twice the magnitude of 17. That means this vector is twice the length of given vector 15i minus 8j. So our vector q will be 2 times 15i minus 8j, which is 30i minus 16j. So the methods were same. I don't know why they gave both the questions. But yeah, these are the answers. B part. Find the magnitude of P plus Q and the angle this vector makes with positive x-axis. Alright, P plus Q. So P plus Q will be minus 15I plus 36J. That was it, right? Minus 15I plus 36J, and Q. Q was 30I minus 16J. So what will that be? Minus 15 plus 30 is 15I. 36 minus 16 plus 20J. They're asking us to find the magnitude of this. So P plus Q magnitude will be square root 15 square plus 20 square, which is 225 plus 400 square root 625. Square root of 625 is 25 units. That is the magnitude. Now, second part is the angle this vector makes with the positive x-axis. Let's try to visualize this. The vector is 15I plus 20j. 15, suppose it is here, and 20 here. So 15I plus 20j will be this vector. Okay, and they're asking us to find this angle. Let's call it theta. We know that the y, this height is 20. This length is 15, and we can use tan theta to find angle. Will be opposite 20 over adjacent 15. So theta is tan inverse 20 over 15. And let me use my calculator to find this. By the time I do this, I would request you to subscribe to my channel, like and share this video with your friends. This will motivate me to make more videos and your knowledge will be shared throughout the world. Thank you. So when I put tan inverse 20 over 15 in my calculator, I got 53.1 degrees in degrees. They have not specified whether we have to write in degrees or radians. So this is the answer. There it is. This is a graph given of a function. Function's equation is given here. Okay, and there is some shaded part. The diagram shows part of this function and line x equal to 4 and 2y equal to 9x. Find the coordinates of the stationary point of the curve. So the lines are not important in the first part, just we have to find the stationary point of the curve. If we try to find it, it will be somewhere here. This is the stationary point, right? Here it is almost turning back. So for stationary point, the gradient of the tangent is 0. That means gradient of tangent, which is dy over dx, should be equal to 0. In other words, they're asking us to find dy over dx of this particular function here. So 2x is easy. The differentiation of 2x is just 2. 5 over x minus 1 is the one which will be difficult, not difficult but little challenging. Can I write this as 5x minus 1 to the power minus 1? That will make it easy. Because it is a power of a function, this minus 1 will go and multiply with 5, so we'll be getting minus 5 here. The contents don't change, and this exponent goes down by 1, so minus 1 will make it minus 2. Further, we should multiply it by the differentiation of x minus 1, which is 1. So multiplying by 1 does not make any difference, so we will leave it. Let's simplify this. Minus 5 over x minus 1 square plus 2. This is dy over dx, and this is what we have to make equal to 0. Because we are trying to find the x coordinate of the stationary point. So to get the value of x minus 1 square, let's bring this 2 to the right side. So minus 5 over x minus 1 square will be equal to minus 2. Let's cancel out both the minuses. So what are we left with? We can cross multiply. So 5 equal to 2 times x minus 1 square, and this 2 can come to the other side. We divide both sides by 2. 5 over 2. x minus 1 square equal to 5 over 2. Now we will square root both sides. So what will we get? Plus and minus here, and this square and square root cancel out. So x minus 1 equal to plus minus square root 5 over 2. X will be, this minus 1 will come and become positive here. 1 plus minus square root 5 over 2. Does that make some sense? No, they have not given any scale here, so we can't verify it. But I'm sure this is the answer. Alright, but they said find the coordinates, not coordinate. That means both of them has to be substituted in this equation to get the y coordinate. So y equal to 5 over x minus 1. Let's put 1 plus square root 5 over 2 in place of x, and then minus 1 plus 2 times 1 plus square root 5 over 2. Let's put this in our calculator, we'll get the y coordinate. I got y equal to 2 plus 2 square root 10. So they're saying stationary point. That means the other point will be somewhere on the negative side. So I'm not going to get that one. Let's write this one. The coordinates are 1 plus square root 5 over 2, 2 plus 2 square root 10. Both are positive, we can see that. If we convert it to decimal, I get 2.58 and 8.32. There's no need to find the second one. Great. So what next? Given that the curve and line 2y equal to 9x intersect at 2, 9, find the area of the shaded region. So they have already made our job easy by giving us this point, 2, 9, this one. So if we draw a line downwards, we already know the area of this triangle. We can find it easily. What is the area of a triangle? Half base times height. Half, what will be the base of this triangle, which is this horizontal line, will be the x coordinate of the point of intersection, which is 2. What is the height? The y coordinate is the height. And 2 and 2 cancel, 9 units square is the area of this triangle. Now only question left is this one. This is x equal to 2, this is x equal to 4. We have to find the area under the given curve from 2 to 4. And that will be the one we'll be doing now. 5 over x minus 1 plus 2x. Okay. 5 over x minus 1 plus 2x dx, and we want it from 2 to 4. Alright, so we'll take care of the limits later. Let's write 5 1 over x minus 1, the first one, dx plus 2x, 2 outside, only x dx, and we'll integrate this. 1 over x minus 1 will be 5 ln x minus 1 divided by the differentiation of what we just converted to ln, which is 1. The differentiation of x minus 1 is just 1. Plus 2x square over 2, 2 and 2 can cancel, plus c from 2 to 4. Now we bring back the limits, and now just substitute the values and we'll get it. Let's do it here. Okay, so first is 4. 5 ln 4 minus 1 over 1, no need to write it, plus 4 square plus c minus 5 ln 2 minus 1 plus 2 square plus c. So this c and this c will cancel because there is a negative in between. Alright, so what are we left with? 5 ln 3. 4 square is 16. Then minus 5 ln 1. Ln 1 is 0. So this is not to be counted. Minus 2 square is 4. So we got it. 16 minus 4 is 12. Plus 5 ln 3 is the area of the shaded part under the curve. We will add what to it? What was the earlier one? 9? 9 units. So total area equal to 9 plus 12 plus 5 ln 3, which will be 21 plus 5 ln 3. If you want to convert it to decimals, that will be 26.49 units square, or you can change it to 3 significant figures, 26.5 units square. Question number 9. An AP has first term A and common difference D. The third term is 13 and the 10th term is 41. So third term A3 is 13 and 10th term is 41. And we know that nth term of an AP is A, the first term, plus n minus 1 D. Let's use this formula for both the cases. So A3 will be A plus 3 minus 1 D. It is 13. So it gives us an equation A plus 2D equal to 13. Similarly, A10 will be A plus 10 minus 1 D, which is equal to 41. So A plus 9D equal to 41. So let's subtract this equation number 1 from equation number 2. I will write it under equation number 2. And let's subtract. It cancels out. 9 minus 2 is 7D equal to 41 minus 13, 28. So D is 28 divided by 7. It's 4. Now we have to find A. Let's use this equation to find A. So A plus 2 times D. D is 4 now. We have found it. Equal to 13. A is 13 minus 8. This 2 times 4, 8 goes to the right side, becomes negative. A is 5. D is 4. Next part of this is find the number of terms required to give a sum of 2,555. So Sn is 2,555. They are asking us what is this n. So the formula for sum of n terms is n over 2, 2a plus n minus 1 d. So a we got was 5 and d is 4. So 2,555 is equal to n over 2. 2 times a is 5 plus n minus 1 d is 4. So n is the only unknown part here. We can simplify this. First of all, we'll get rid of this 2, multiply both sides by 2, so that this 2 is cancelled out. So it comes out to be 5,110. Double of 2,555. Okay, will be equal to n, this is 10, plus n minus 1, 4. So let's multiply 4 with n. It gives us 4n minus 4. So 10 minus 4 is 6. 5,110 equal to 10n, this 10 and this n multiplied. 4n plus n multiplied 4n square. And then minus 4 times n is minus 4n. 10n minus 4n will become 6n. So let's collect everything to the right side. So 4n square plus 6n minus 5,110 will be the quadratic equation, and we will find the solutions of this quadratic equation. Obviously, it seems one of the n's will be negative, which we will not accept because n cannot be negative. And to find those solutions, we will use quadratic formula. Quadratic formula is here A is 4, B is 6, and C is minus 5110. The quadratic formula is minus B plus minus B square minus 4AC over 2A. So it becomes minus 6 plus minus square root 6 square plus minus 4 times A C over 2 times 4. So minus 6 plus minus square root 36, and this minus will make it positive, and 16 times 510 will be 0, 6. Okay, over 8. So now minus 6 plus minus the square root 796, 286 over 8. So what are the two answers? Minus 6 plus 286 over 8, minus 6 minus 286 over 8. We know this will be negative, so negative we will not accept. Let's talk about the positive. Without positive, it will be 280 divided by 8, which is 35. So this gives us n equal to 35. We have one more part of this. Given that Sn is the sum of n terms, as if we don't know it, show that S2k and Sk is this. Okay, so Sn, we already know the formula for Sn, so we can, let me write the formula first again. N over 2, 2a plus n minus 1 d. So S2k first. Let's focus on this. It will be 2k over 2, 2a plus 2k minus 1 d. Sk will be k over 2, right? In first case, I replace n by 2k. In second one, I'm just substituting n by k. So it will become 2a plus k minus 1 d. Now we have to show that the difference is 3k 1 plus 2k. So let me write it somewhere so that we can compare it later. Alright. So S2k minus Sk will be 2k over 2 times the first term 2a, which is 5, plus 2k minus 1 d. d is 4. Now Sk, k over 2, 2 times 5 again, plus k minus 1 this time, times 4. This should be equal to this one. Alright, so let's try to simplify this one first. 2 and 2 cancel. K stays out. 2 times 5 is 10. And let's open this bracket. 4 times 2k will be 8k. Minus 4 minus k over 2. And open this bracket as well. 2 times 5 is 10 again. Plus 4k minus 4. So in these brackets we can say 10 minus 4 is 6. So k 6 plus 8k minus k over 2, it will again be 6 plus 4k. Okay, so we can see here 1 plus 2k should be there. So do we have 1 plus 2k somehow? No, we have to simplify this. So let's open this bracket. 6k plus 8k square minus k over 2 multiplied by 6 will be 2 and 6 will cancel out, so it will be 3k. K over 2 times 4k will be minus 2k square. 6k, not 6k, 8k square minus 2k square will be 6k square. 6k minus 3k will be plus 3k. And now this is the simplest version. If we take 3k common out of these two, we'll be left with 2k in this one, and 3k is all out, nothing is left. When nothing is left, we write 1, and you can see it is exactly what they wanted. Alright, Next one, it is given that fx is this polynomial function. Find the equation of the normal to this at x equal to 1. Very straightforward question. So we can first write what is the equation of a normal. Y minus y1 equal to minus 1 over m x minus x1, where x1 and y1 are the points on the curve where we want this normal. So we already know x1 is 1, so we have to find y1. Substitute this x equal to 1 into the polynomial and we'll get its y counterpart. 4 1 cube minus 4 1 square minus 15 times 1 plus 18. So that is 4 minus 4, cancel out, minus 15 plus 18, y1 is 3. So we got this as 3, y and x are general terms, so we won't change them, x minus 1. Now m is left, m is the gradient of tangent. And that's why for normal we have written minus 1 over m, because the gradient of normal is negative reciprocal of gradient of tangent. And gradient of tangent is nothing but dy over dx at that specific point. So let's find dy over dx of the given polynomial. It's 12x square minus 8x minus 15. When x is equal to 1, what will be the dy over dx? That will become m at that point, which will be 12 1 square minus 8 times 1 minus 15. So minus 23 plus 12 minus 11. Okay. So now we will put here minus 1 over minus 11. So they cancel out. This becomes the equation of the normal. Y minus 3 equal to 1 over 11 x minus 1. Next part, do not use a calculator in this part. It is also given that x plus a is a factor of fx, the one which is given up. What was that? 4x cube minus 4x square minus 15x plus 8x. Okay, so fx is 4x cube minus 4x square minus 15x plus 18. This is a factor of this. That means if we divide this polynomial by x plus a, the remainder will be 0. We could have used remainder theorem here by substituting minus a, because x plus a, if you make it equal to 0, x is equal to minus a, and minus a becomes the root. If you substitute a in place of x, that is not going to make any difference, because this equation will be in terms of a now. So let me do what? Let me factor this one directly, and the integer that I will get, one of them will be my a, right? So to factor the polynomial, we just focus on the number part, and because they are saying it's an integer, we'll focus only on integers which are the factors of plus 18. And let's start with the simplest one, plus minus 1, plus minus 2, and plus minus 3. I'm sure one of them will be a solution of this. One of them will make it 0. If plus 1 is a factor of this polynomial, we'll get a 0. But we did not. Remember, when we plug in 1, we got y equal to something else. So 1 is not. Let's say minus 1. Put minus 1 in place of this and see if you're getting a 0. So if I try that, 4 minus 1 cube minus 4 minus 1 square minus 15 times minus 1 times plus 18. So it will become minus 4, and this will become minus 4 minus 15 plus 18. No, it is not coming out equal to 0. So 1 and minus 1 are not the roots. Let's go to plus 2. 4 2 cube minus 4 2 square minus 15 times 2 plus 18. It becomes 8 times 4, 32, minus 4 times 4, 16, minus 32 plus 18. Almost there. These two cancel, but they don't give us a 0. Let's see, 4 minus 2 cube minus 4 minus 2 square minus 15 times minus 2 plus 18. This will be minus 8 times 4 minus 32. 4 times this one is minus 16. Yeah, this will be 30, positive 30 and 18. And yes, 32 plus 16 is 48, negative 48 plus 48, 0. Yes, we got our answer. X is equal to minus 2. So A will be positive 2. This is the root. Now, they're also saying that find A. We found it by hit and trial. And then solve the equation fx equal to 0. Since we already know one of the factors now, we can find the rest of it. So x plus 2, yeah, when 2 comes to the left side, it becomes x plus 2 equal to 0, and this x plus 2 becomes the factor of the given polynomial. We'll divide by long division. It will be 4x cubed minus 4x squared minus 15x plus 18. We'll divide it by x plus 2. Let me do it fast. So we got it. The factors are x plus 2 already known to us. Second one is 4x squared minus 12x plus 9. And we can use factoring method to factor the second part also. Let me do that. So we got the factors 2x minus 3, and obviously they are not giving any integer. That's why this was out of it. So the final equation we got was x plus 2, 2x minus 3 square equal to 0. This gives us x plus 2 equal to 0, already known to us, x equal to minus 2. This gives us 2x minus 3 equal to 0, which is 2x equal to 3, x is equal to 3 over 2. These are the two solutions.